Hey everybody, I have a lot of respect for this guy, David Altizio. He freely admits that some of these problems, this problem in particular, this Olympiad problem, employs what he calls obfuscation, and that's not something that seems too ethical. But he freely admits that that's what happens, and so he practices creating problems that involves these obfuscations. Obfuscation meaning something that is an intentional diversion to confuse you, which may be considered fair in math competitions, but a lot of people would look at it as not towards pure mathematics, but just an act of deception. I don't know what I think about it, but anyway, I appreciate his honest commentary. Now, this part right here would be what he would refer to as the obfuscation. This inequality that involves constants, okay, is the obfuscation. And then up here is the more general truth that involves general constants A, B, C, and D, and there's a relationship between A, B, C, and D, okay? This is easy to prove. It turns out you can prove this via Cauchy Schwarz fairly quickly, but if you just look at this problem, you may not think of Cauchy Schwarz. So having the more general truth is actually the simpler approach in David's mind, and I sort of agree with him on that, okay? Not that that's important, but anyway, hopefully you can read this okay and go review some of his work. He wrote tons of really interesting problems, and I think he dropped out. Now he's just a pure mathematician somewhere. But anyway, I appreciate the effort that he put in on writing competition level problems. It's a challenge to do it right. It's a challenge to have one little trick in there, figure out a way to make a problem that's not just simple to work, but you need a little trick that you have to see to make the problem less than trivial, But anyway, let's look at how this would go. The problem that I made up, it's a different set of constants, but it's the same structure. And we're supposed to show that the left-hand side is greater than or equal to the right-hand side. And of course, you can square away and create an equivalent inequality this way, 19 squared over here. So we get something that's a little more palatable, in my opinion. And then those of you familiar with Cauchy Schwarz recognize quickly that this is just Cauchy Schwarz. Okay, Cauchy Schwarz all the way. You can think of the right-hand side as a norm or a dot product, inner product. No, left-hand side, but anyway, this is, and I'll just come down here. If you're not familiar with Cauchy Schwarz, you can see how the right-hand side looks like this. You've got, these are like a vector, two vector dotted together squared is what this means. You don't have to really think of it as vectors here, but you can see clearly the A sub i's would be the constant 6, 10, and 15, and the B sub i's would be the variables here, and you can see that. And what I did is I just square rooted both sides from here. Or I hope you can see that, but this part right here is exactly in this form right now, okay? And then you square root both sides and you get something that is obviously, you can stop right here if you wanted, as long as you know that's equivalent. But really just the key thing to observe right here that makes it fly actually is that the constant 6 squared plus 10 squared plus 15 squared is equal to 19 squared, it turns out. Okay, now you can do the calculations if you want, but 19 squared is 361. I believe, yeah, it's 361. I have it written down there. So that needs to happen in order for this thing to work out. And you can see that would be right here. This part right here with the sum of all the squares would, without the square rooting going on, this would just be 361 right here. Okay. All right, as far as the associations with this particular problem here. So in other words, this is just true by Cauchy Schwarz, and that's it. I mean, that's all I have for you. Here's a statement of the Cauchy Schwarz inequality, and you're not going to have equality under these circumstances because of the quotients of the proportional, I guess. The quotients of the individual coefficients have to equal to each other. Okay, and that's not the case here, of course. But so anyway, that is it, folks. And again, I want to say thank you again to David. Appreciate his work. I don't think that he does the problem writing much anymore. He tries to maintain these things pretty quickly, and he rightly leaves out the solutions in many cases. But I've enjoyed many of his problems, and this is one of them, And I just appreciate the honesty of a gentleman who will tell you that something that people might think is kind of slimy, obfuscation. You mean that's what's going on with these problems? They're trying to confuse you by being deceptive. I mean, that's what my understanding of the word obfuscation means. Apparently, he may mean it be just a problem-creating technique that makes the problem hard, and that's fair. All's fair in love and war, right? But anyway, thank you again, David, for the excellent content related to how to write problems and so on.